What does Comde Derenda do? Nowadays, people are concerned more and more about PM 2.5. We've established its harm, so how do we monitor its concentration in our environment? The principle of gravimetry is taking air samples at a constant flow rate via the sampling inlet, making specific particulate samples trapped on the blank filter with the known mass, and calculating the concentration according to the mass difference between the pre- and post-sampling filters, as well as the cumulative sampling volume. This seems easy, but it is actually very troublesome. A lot of filters and statistical data are needed for the sampling and weighing process. Staff need to carry the filters between the sampling sites and weighing lab, all while recording relevant data, making accuracy very difficult. Conventionally, we start with numbering, weighing the blank filters and recording the weighing data, then deliver them to the dust sampling sites. After sampling, we carry the loaded filter to the weighing lab and run the weighing steps again, then record data and match the numbers of the pre- and post-sampling filters, so that the mass concentration on each filter can be calculated correctly, all done manually. Additionally, the laboratory should achieve precise requirements of constant temperature and relative humidity, as well as the anti-shock and anti-static conditions. To ensure the reliable weighing results under such strict conditions is as difficult as you can imagine. How do we improve the work efficiency and reduce errors while releasing manpower? We have achieved an overall intelligent solution based on the robotic and cloud technology. Let's explore how this system works. Ideally, this system will oversee data exchange of filters, samplers, and weighing system, which is based on the radio frequency identification, also known as RFID. We have the new generation of automatic weighing system, AWS, and the fourth generation of sequential PM samplers, PNS, and a special filter cassette with an integrated RFID chip, which is responsible for the data communication between the two instruments. Now, let's get to know the system. Step 1. Pre-sampling filter weighing. Place the blank filters onto the RFID ring and load them into the filter magazine tower of AWS. Launch the weighing process after 24 hours of conditioning at constant temperature and relative humidity. Meanwhile, the RFID terminal reads the ID number of each filter and writes corresponding result into the RFID chip. Step 2. Filter sampling. Place the filters into the PNS sequential samplers. Run the sampling task for 18 filters. Meanwhile, the RFID terminal of PNS reads the ID number of each filter and stores corresponding sampling data. After the sampling task, deliver all the filters with RFID ring to AWS for the last weighing step. Step 3. Post-sampling filter weighing. All the loaded filters will be weighed in sequence by AWS, and the weighing results of pre- and post-sampling will be recorded under the same ID. The cumulative volume and the other sampling data should be matched as well. Meanwhile, AWS will receive and transfer all the detailed weighing and sampling data to the cloud server. Here, the mass concentration of each filter can be calculated accurately by using the relevant data. RFID cassettes can be reused, meaning less materials for large amounts of work. Historical data and the status of each filter are easily tracked by using your smartphone or PC to connect the cloud server. The entire process is well controlled and can track any artificial tampering. And who are we? We were founded in 1972 in Germany. and we now provide world-class particulate measuring technologies in over 30 countries. Comde Derenda. We are precision and accuracy.